Hello and welcome to another tutorial session on my YouTube channel. In today's presentation, we are going to be looking at Northwest Regional Mock for Pure Mathematics in Mechanics, Paper 2, March 2016. I will begin with the first question. Before we get to the questions, please, if you are new to my channel, kindly hit the subscribe button, as it also encourages me to continue creating these videos to aid your studies. Now you can get to me using the number on the screen on WhatsApp. That's my WhatsApp number. If you have any difficulty or you want to ask a question, feel free. You can reach me on WhatsApp using that number. And please, after watching this video, make sure you share the video so that it goes viral. And also like the video, please. It's important for me. Now let's get the question proper. Now the question reads, the first part, given the quadratic equation 3x squared minus x plus 2 equals to 0, and they say given that the roots of the quadratic equation are alpha and beta, form a quadratic equation whose roots are alpha over beta plus 1 and beta over alpha plus 1. The B part, the Roman numeral 2, says express x to the x divided by square root of 2x plus 1 as a series in ascending powers of x and including the term in x cubed. And by using the substitution x equals to 1 over 7, show that root of 7 is approximately equals to 261 divided by 98. So our quadratic equation has been given to us, which is 3x squared minus x plus 2 equals to 0. So dividing all through by 3 gives us x squared minus 1/3 x plus 2/3 equals to 0. Now we know that any quadratic equation can be written in the form x squared minus sx plus p equals to 0, where s is the sum of roots of that equation and p is the product of roots. So comparing with these two equations here, we can see that our sum of roots is what? 1 on 3, while our product of roots is what? 2 on 3. But in the equation we are told that the roots are alpha and beta, so our sum of roots is denoted by what? Alpha plus beta equals to 1/3. I've already seen that. And then the product of root alpha beta will be equals to what? 2/3, as we can see clearly on the screen. Next, from here now we have to form a quadratic equation whose roots are this. Now we have to look for the new sum. These are the sum of the old roots. This is the product of the old roots. So I have to look for the new sum. So the new sum now will be what? Alpha on beta plus 1 plus beta on alpha plus 1. That's the first root plus the second root. And when you add these two fractions by the common denominator, when you want to add two fractions with different denominators, the common denominator, it will just be the product of the two. That's the easiest way to see it. So that when we take this denominator and divide by beta plus 1, it will give us, you will be left with alpha times alpha at the numerator. You have alpha into alpha plus 1 plus beta into beta plus 1 when you do that. And now simplifying a little bit, expanding this, to get alpha squared plus alpha plus beta squared plus beta. Bringing some terms together and simplifying, you get that I group all the terms with a square. Alpha squared plus beta squared plus alpha plus beta divided by the denominator. When you expand, you have alpha beta plus alpha plus beta plus 1, which is that. Now from here now we know that alpha plus beta, alpha squared plus beta squared, is an identity that can be replaced with alpha plus beta all squared minus 2 alpha beta. Then copy what is left, alpha plus beta, and the denominator remains the same. Now that we have alpha plus beta and alpha beta, we just substitute everything there. That will give us what we have here, and then upon simplifying this leaves us with negative 4/9 when you simplify all of this. Now after having a new sum, we also need what? A new product. So our new product will simply be what? Alpha on beta plus 1 times beta on alpha plus 1. That's, you just multiply the two roots, the first root times the second root. Now this is a multiplication of two fractions. To multiply two fractions, we simply multiply the numerators separately from the denominator. So at the end of the day, we should have alpha beta divided by what? Alpha beta plus 1 times alpha plus 1, and this is just the product of this denominator here, which is that. So we'll just copy and replace it to get that. Since we have already expanded alpha plus 1 plus beta plus 1, I just copy and paste, because this is a problem most students face. You keep on writing one and the same thing, meanwhile you have already done it. So to avoid that, it's always good to be observant with your work, what you have in front of you, so that you don't waste a lot of time doing unnecessary calculations. Now from here, since we have everything in place, alpha plus beta, we know the value 1/3, alpha beta 2/3, and we have also calculated, take notes, we have also calculated this denominator here. When you add this denominator here, it will give us what? 3/3, which is 1 plus 1, 2. So I'll just come and replace the answer here. There's no need coming and substituting everything again. It just makes the work long for nothing. So at the numerator, we have alpha beta, which is 2/3, and then alpha at the denominator, when you substitute everything as we had here, you just come and put the answer there, and when you simplify all of this, it will give us 1/3. So our new equation now will now be what? Remember, any quadratic equation can be written in the form x squared minus sum of roots times the variable in which a quadratic is defined plus the product of root equals to 0. With this now in mind, I can now write the quadratic equation as follows. We have x squared minus sum of root. The sum of root is negative 4/9 times x plus the product of root, which is 1/3. And from this stage now, negative times negative gives us what? Positive. So that we can now multiply both sides by the denominator, that's by 9, because it is it divides 9. 3 is a divisor of 9, so we can easily multiply both sides by 9. It will make some sense to have 9x squared plus 4x plus 3, because here negative times negative gives a positive and equals to 0. So this is a new equation. Please, if you have not subscribed, kindly hit the subscribe button, and don't forget to turn on the notification bell, so that whenever I will upload the other parts of this particular paper, you will not be left out, you will not miss anything. Please don't forget to subscribe. Now moving forwards, let's look at the Roman numeral 2 of the question. It says express this as a series in ascending powers of x up to and including the term in x cubed. This is very important to note. You have been asked to end at the term in x cubed, so there should be no reason why you should expand and go and exceed x cubed. So to expand this, you have to record that this can be written as x. Remember, the denominator is what? 2x plus 1, all raised to the power half. When it goes at the numerator, the power becomes negative. So this thing is identically equals to this. X equals to what? 1 plus 2x raised to the power negative a half. Now that x is just a polynomial, a linear factor, we can just leave it there. All we need to do is to expand 1 plus 2x raised to the power negative a half, and then now multiply the answer by x. So since we are ending at the term in x cubed, it means that when we expand this in ascending powers of x, we should end at x squared, because when we multiply the answer by the highest degree here by x, it will give us and x cube. So we end at x squared. So that's why I have to be very observant. Now, why are we going to use 1 plus 2x instead of 2x plus 1? The difference between these two expansions using 1 plus 2x instead of 2x plus 1 is because we are expanding in ascending powers of x. If you use 2x plus 1 and apply the binomial theorem here, you have an answer in descending powers of x. It's important to know that. The reason why I wrote it like 1 plus 2x is because I want to expand in ascending powers of x. So now we have to recall the simplified version of this expansion. When I have an expansion like this, it is true for all real numbers. It can be a fraction here for n. It can be what? Anything. It can be a radical. It has been proven to be true. Normally, this is an extension, a simplified version. It has been simplified using the binomial theorem. So when you have expansion of this form, where you have 1 plus a linear factor like this raised to some power, you can just use this directly rather than go returning back to the binomial theorem. So that's why it's always good to keep some shortcuts in your head, some short expansions in your head. Now, we're going to use this expansion just by replacing x by 2x, and our n here is what? Negative 1 by 2. So that's what we have initially. So expanding this, I have x into this expansion. To expand this now, I will simply replace x in this expansion that I have here by what? Negative by 2x, and n by negative a half. So doing that, I have the first term, which you can see n is negative a half, and then my x has been replaced with 2x, as you can see clearly. Divide by 1 factorial. You do the same thing here, and when you simplify this one will give what? 2 cancel 2, you are left with negative x divided by 1 factorial. 1 factorial is 1, so you'll be having x into 1 minus x, and this one here will give you what? Negative 3 over 2, and negative 3 over 2 times negative 1 on 2 will give a positive, so that will give me what? 3 over 4. And when you square this 2, it will give us a 4, so that one will just cancel out, leaving out 3 at the numerator, and x square, we have it there, and 2 factorial being 2. So when the reason why I stop at x squared is because we want to expand and end only at x cubed, so that if I multiply this one now by the highest degree of this polynomial inside here, you will have what? Our x cubed, which is our desired ending. So going forward, you just open up, we have x times 1 is x times this negative x squared, x times this 3 on 2 x cubed, and that is the answer to the first part of the second part. That's the first what was required. Now they say we should replace x by 1 on 7 and show that root 7 is approximately equals to this. Remember, this expansion is valid only when x lies between what? Only when the absolute value of 2x is less than 1. That is, x lies between negative 1 on 2 and 1 on 2. It's important to know that. And 1 on 7 is in that interval, so it makes sense. We can use it to do the calculation. So when you replace x by 1 on 7, this expansion is equals to this. So I'll replace x equals 1 on 7 here on the left hand side and simplify. So we're going to replace it on the left hand side. That will give us 1 on 7 divided by square root of what? 2 times 1 on 7. So since s is 1 on 7 plus 1. Now at the numerator we have that. At the denominator we have 2 over 7 plus 1. That is what? 9 over 7. And the square root of 9 is 3 divided by root 7. This division of two fractions, when you do that division, you should end up with root 7 on 21. Now going forward, we also have that what? The square root on the right hand side, this right hand side here, we replace x by 1 on 7 and when you simplify all of that, it will give us 87 on 686. Now, since we have replaced the same 1 on 7 on both sides of the equation, and this expansion is equal to this, so that it means that the left hand side must be equal to the approximately equal to the right hand side, almost equal to the right hand side. So we have that what we have here on the left hand side, root 7 over 21 it should be almost equal to what, 87 divided by 686. And now all you need to do here is to make root 7 the subject, multiply both sides by 21, and it gives us the proof as required. So that's the end of this paper. I thank you for watching. Please, if you are new to this channel, I still insist, please support us by subscribing. It's very important for us, because if you don't do that, it is not an encouragement. We will not be encouraged to continue creating content for you. So please hit the subscribe button and share the video. Share to your friends, students, and all your friends in class. Share to them. Please, if you are a teacher, you can also share to your students. Let the video go viral. I thank you all for watching, and stay tuned for the other upcoming parts of this same Northwest Mock 2016 Pure Mathematics Advanced Level. Bye bye.